Welcome back to the Jill and Jason update. This is week 8 of the Covers Engineering Evaluation Test 2. We're still up here at Camp Grayling, and boy, these fall colors sure are shining through. So this week we're focused on the warfighter machine interface, really how that robotic operator interacts with the robotic system. We also have one of our CCDC partners, C5ISR here. They're bringing the degraded comms and Blue Force tracker technology integrated into the warfighter machine interface.
Even though this is a GVSC-led event, this is really a CCDC-wide activity. We got C5ISR coming in, we have people from academia and industry. It's just really great to be building a community. The other thing that's awesome about this week is that we're working on the technology that the soldiers are interacting with. This is how they experience robotic systems, it's how they're going to use them. And so every bit of effort that we put in now is going to make the soldiers' ability to use robots in the future that much better.
So let's dedicate this week to all the current and future robotic operators. The warfighter machine interface is really that user interface that a soldier would be interacting with to control the robotic asset. We're building up the software internally within GVSC to really make the best product that the soldier would be able to operate these vehicles with. So we allow the operator or the soldier to be able to teleop the vehicles all the way into operations with full autonomy. So we have to build the software to encompass all of that.
The cover program is using the WMI as primarily the control interface for research and developing new autonomy features, new formation features, as well as new behaviors throughout GVR, as we're having people who've never used the system before try to use it with minimal training, and then we compare that to an expert person who would normally use that.
The WMI actually brings an aspect of situational awareness to the operator that, very much offers an advantage. For instance, when the robotic asset is in an autonomous mode and the sensors, build the map that it has to maneuver through. It identifies obstacles, it identifies routes that it needs to take. But if a manned or an operator was driving it manually, they might take a particular course. When the vehicle in an autonomous mode doesn't take that course that the manual driving would be, it could be questionable to the operator. So we provide that information. So not only the cost map, but some of the LiDAR data, we provide that to the operator so they can fully understand the reasons the robotic vehicle is choosing to take that particular path. Ultimately, it is just giving them that situational awareness of why and the state that the vehicle is in.
The capability that we are working on includes taking BFT, SATCOM, or BFT2 SATCOM, integrating that equipment onto the manned fighting vehicle and working in cooperation with GVSC.
So we identified what we thought to be a number of high priority messages for data exchange between the mission command software applications and the vehicle control software. And those were identified to be position reports, so they're sharing position and location information about the robotic vehicles. And we do some free text messaging and some spot reports, which is identifying enemy locations in the battlefield. That's what we've kind of enabled here. So from the WMI system, you're allowed to share that information bidirectionally with the mission command software. A robotic vehicle can potentially become orphaned from its controlling vehicle. So right now, there's a kind of a fail-safe where the vehicle might return to a preset location. But since we have this SATCOM connection, it enables us to dynamically set a contingency point for the robot to go to in case of this failover scenario. So we have a software service that runs on board the vehicle, and it listens for a connection with the WMI software. And if that goes away, it's assumed that the robot has lost communications with the controlling vehicle. So in which case, our software service kind of takes over and it starts pulling information from the robotic toolkit and reporting things like position and status over the BFT network rather than the terrestrial network that's normally used.
By adding BFT, and the SATCOM onto these vehicles and exchanging the data up via the satellite to the network operations center. Not only does it enable these semi-localized GVSC groups of assets to be able to see each other, their positions, and exchange data, but big Army as well. This is a nice example of under CCDC, both GVSC and C5 cooperating in a development effort to get at some real problems that currently exist that need to be solved.
Thanks for tuning in to the Jill and Jason Update.
See you next week for some perspective from leadership.